I will make an assumption by saying that you work in some capacity or another with Kubernetes and that you're interested in making management of your clusters much easier, much better, and faster with AI. If that is the case, I have a treat for you. We will explore how to do just that. We will take a look at an AI agent specialized in management of Kubernetes clusters. An agent that comes from the company that made Kubernetes. An agent that is open source. An agent that has the potential to be one of the most important tools in your tool belt. Today we'll see how you can use AI to manage resources in your Kubernetes clusters through an agent which should do a better job than any other agent, mainly because it is specialized. Specialized tools tend to be better than generic tools within the area they're specialized at. Otherwise, we wouldn't be making them, right? Let's see. We'll take a quick break for me to introduce you to UpCloud, the sponsor of this video. So, here's the story. It does not matter whether you write code or manage services or whatever else with AI if you don't have infrastructure to run your applications and databases and whatever else you need to run. The things that you generated or half generated with AI. That's where UpCloud comes in. It is a cloud provider focused on high performance, low cost, and global availability. That's important since most of the providers do not do all three of those. You can easily find high performance but expensive provider. You can also easily find cheap provider giving us old hardware, high latency, or not global availability. UpCloud is worth checking out. It is a modern cloud platform. It's made in Europe. It has 24/7 support. It has all the services you might need, and it does not charge internet transfer fees. Please use the link on the screen, somewhere there, or in the description, and you'll get $50 or 50 euros actually in free credits, extended trial of 30 days, and unlimited usage. Check it out. Big thanks to UpCloud for sponsoring this video, and now let's go back to the main subject. Right now we're in a kubectl-ai terminal session and we can ask it anything about the Kubernetes cluster we are connected to. We can, for example, check what the state of the cluster is. As a result of that prompt, kubectl-ai retrieved all the nodes and all the pods in the kube system namespace and all the pods in all namespaces that are running. Now, that last operation is silly. Why would it retrieve only ready pods if we ask him or it or her what the state of the cluster is? If anything, it should have returned everything but ready pods in hope that it would find those that are failing or pending or in any other non-ready state. Anyways, we'll ignore that for now and focus on the conclusion. It found out that there is a single node called .control plane and that it is ready. It figured out that the stuff that composes the control plane is running correctly. Amazing, right? Well, no, not really. If you did not pay attention to what is executed, we might be delighted to see that there are no pods in a failed or pending state. We could congratulate ourselves on yet another day without any incidents and open a bottle of champagne to celebrate. The problem with that statement is that it is a conclusion based on a wrong observation, and that I know that there are issues in that cluster since I set it up with a few issues intentionally. I'm a mean guy who set a trap and kubectl-ai fell into it right away. I was hoping that would happen because I'm evil, but I did not expect it to happen so soon. Nevertheless, anyone working with AI knows that mistakes are common and that we should always verify claims. So let's do just that by asking it to check the whole cluster in hope that all, the word all, will make it work a bit harder to determine what's going on. After a bit of work, it managed to get out of the silly trap I set for it. It figured out that there's something wrong and it identified the key issue. There's something wrong with the ACK EC2 controller running in the ACK system namespace. Now, that over there was useful. It's not groundbreaking, but useful nevertheless. That's what was to be expected from an AI agent dedicated to Kubernetes. Now, let's see whether it can fix it. After checking logs of different pods and retrieving a few deployments, it came up with the instructions what we might need to do. Now, this is good and bad news type of a situation. The good news is that it did provide instructions how to fix the issue. As a matter of fact, I am pleasantly surprised that it figured out that the problem is not directly related only to Kubernetes. It understood that we need to set up AWS search set to fix it. It probably got that from logs, but I'll still give it credit. The bad news is that it is an agent focused only to Kubernetes and, as such, incapable of performing operations outside the cluster. It does not have the capability to interact with AWS. Now, I guess that's okay. I did not expect a Kubernetes agent to do anything outside a cluster. Now, whether that's a good or a bad thing is something we'll talk about later. In any case, I still expect AI agents to clean up my shit instead of me copying and pasting commands. So let's see whether it can do what needs to be done if you give it the information it needs. That should work. It claims that if you give it the account ID and the role name, it will do what needs to be done. And that's awesome. So let's try it out. And look at that. Now we're talking. It suggests that we should annotate the service account and waits for the confirmation to do just that. Now, to be clear, the AWS account I provided is fake, so it would ultimately fail. And that's okay though. The important part is that it correctly identified how to fix the issue, and it is now working on a fix for it. It's awesome. It's really awesome. Okay, what should we do next? Let's see whether it can correctly identify what is running in that cluster. Now, while it's working, let me stress that I'm not looking for a simple list of pods or deployments or custom resources of something similar. I wanted to explain what is really running in the cluster. I want to get information beyond what I would get by manually executing kubectl-ai deployments or a similar command. Look at that. That's nice. Even though it was to be expected. The agent executed a few queries, sent the outputs to Gemini, which responded with descriptions of each of the components running in the cluster. Amazing. Now, how about creating resources? Can you do that? What we saw so far is relatively primitive for an agent. We ask it a question, it goes to Gemini to get the commands what to do, it executes those commands, it goes back to Gemini to interpret the output of those commands, and it shows us the response. I'd like to know whether it can do more than that. I would like to know whether it can be a bit more proactive and, for example, ask questions when it needs more information from us, from me. Let's check that by telling it that we would like to create a manifest with resources required to run an application. Look at that. There is nothing wrong with that answer. We got a template we could use to create resources that compose an application. We got an explanation of what is what, and we are asked whether we would like to create those resources or we prefer to refine it further. The first option is obviously silly. Proposed resources are so generic that it would be pointless to create them as they are, while the second is too vague. So when I think about it, that's a bit disappointing. I expected it to ask us questions from the start. I expected it to ask us, to ask me which type of an application I would like to run, whether it should be exposed outside of the cluster, which image I would like to use, and so on and so forth. I expected it to know better than to output a generic example. Let's fix that by instructing it to create that manifest and also to ask me for the info it might need. Also, we'll tell it not to apply it just yet. And there we go. And what I expected is slightly different. I expected it to ask each of those questions separately. Instead of outputting them all, it would be so much better if we started with the question, what name would you like for the Kubernetes namespace? For it to wait for input, then to ask for a second question, wait for another input, and so on and so forth. That would be so much better. If, on top of that, it offered a list of available namespaces, for example, and asked us to pick one or create a new one, that would be amazing. That was also okay. Nothing it did so far is great or especially impressive. None of the things we saw is bad either. It's all okay, including that output. We'll try to make this and other situations much better later. For now, let's respond to the question it asked. That was a bit better. Due to previous disappointments, I expected it just to output the manifest on the screen, so Due to my low expectations at this point, I'm now pleasantly surprised that it offers to save it to a file. It would be even better if it asked for the name of the file, but this is okay as well. Now, let's confirm that we wanted to proceed. Okay, now let's see whether it can do something slightly more complicated by writing a bit more elaborated prompt. We'll ask it to create a manifest based on one of the crossplane compositions. We'll instruct it to let us choose which one to use as a numbered list, to ask us questions, to collect data, the data it might need, and to save it as a file. Look at it. That makes sense. It did a great job by discovering the available compositions and present the choices. So let's pick any of those. kubectl-ai continuously results in emotional cycles that range from this is okay to this is underwhelming. It went to the old pattern of presenting all the questions and asking us to answer all of them at once, just as it did with the application. It would be so much better if it presented each question separately and when applicable, if it provided choices, like a numbered list, for example. Now, to be clear, 100% clear, many other agents would be making the same mistakes and would often not react in the way we want them to. Fortunately, we can fix that in most other agents, so I'm sure that we can fix that with this one as well. So let's give it a try. Let's fix the issues with this agent. There are two important things we can do to improve the performance of almost any AI agent. One is to make the memories instructions, and the other is the usage of model context protocol. The ability to have some form of memory is important. It allows us to provide permanent instructions that an agent can follow so that we do not need to repeat ourselves over and over again. With memory, we could say something like, hey, you know what? Always ask me individual questions that will provide information you over there might need to create resources. Or never create resources directly. Always save them to a file. That's what we do with memory. Now, given that most other agents can do it, I have no reason to suspect that this one can't. But let's ask it just to be on the safe side. The gist of the answer is that it can remember, but only within our current conversation session. That over there is just silly and semi-useless. We would have to never close the session or save all the instructions in a file and copy and paste them into the prompt every time we start a new session. That's silly. Fortunately, there is no need for an agent to have a built-in mechanism for permanent memory. As a matter of fact, I do not like using built-in memory. It is, in my opinion, a good idea to use an MCP for that, since we can hook multiple agents to the same memory MCP, or we can share memorized instructions with other people in our organization by running the server remotely. That answer also makes the next choice easy. I wasn't sure whether to try combining kubectl-ai with Context7 or with Taskmaster or with some other MCP. Given that it does not have built-in memory, the choice is easy. We'll try to hook it into an MCP that will provide it with permanent memory. We'll fix that. So let's see whether it can use MCP servers. You dummy. You're an AI agent, and given that most AI agents use MCP servers, they are aware that MCP does not stand for Managed Control Plane nor Multi-Cluster Platform. Now, I should not be that harsh though. Those are terms that might have MCP as abbreviations and are used in the context of Kubernetes, so let's clarify. And there we go. Long story short, the answer is no. And I'm very, very disappointed. Let's talk about it. Let's discuss the pros and cons. kubectl-ai is great and disappointing at the same time. I will explain why I think so in a moment. First, let's go through pros and cons, starting with the parts I do not like. To begin with, the agent is very basic. It might not look like that since it is talking to Gemini model, which is one of the most capable models right now. If you judge it only by the answers, it might be easy to conclude that it is great. However, we are not evaluating the model, but kubectl-ai, which is an agent. As such, it could be better. It could be more proactive. It could be asking follow-up questions to get better context from us. It could be collecting and presenting more data. It could be doing many other things that more generic agents, like the one in Cursor or Cloud Code, are doing. That, however, could be fixed if we could provide it with additional instructions how to behave, which we can't. And that brings me to the second negative point. There is no persistent memory. As such, we can make the agent do what we want it to do if we provide it with enough instructions. That part is not a problem. The problem is that those instructions would be gone the moment we close a session, and we would need to go through the same exercise every time we start a new one. All, and I repeat, all agents that I've been using lately have persistent memory. So it would be hard to justify why this one doesn't. Still, that could be fixed as well with an MCP, which brings me to yet another negative point. kubectl-ai does not support MCP servers, which, in my opinion, are one of the most important improvements we got lately. They're crucial for any serious usage of AI, and just as persistent memory, all the agents I used lately support it, except for kubectl-ai. And that's a shame. Finally, kubectl-ai only supports Gemini models, at least today. Now, to be clear, I see nothing wrong in Google releasing a Kubernetes agent that works only with Google models. Only if it would be closed source. That's not the case though. kubectl-ai is open source, and given how easy it is to hook different models to an agent, I expected it to support at least one other model from the get-go. That being said, I do believe that Gemini models are one of the best, if not the best models out there. That is not my complaint. Even if other models would be supported, I would still probably use Gemini. However, not everyone has a subscription to those models, and it would be great if those would be able to benefit from kubectl-ai with whichever model they're using, instead of being forced to use Gemini. Now, let's switch to pros. Right now, what follows might make you feel disappointed to discover that there is only one truly positive thing I can say about it, until you see that it is a big one. kubectl-ai works as an MCP server, and that is huge. I already stated that MCP servers are a very important piece of any agent. While this one does not support them, it can act as one. It can easily be the best MCP server that interacts with Kubernetes clusters, and that's great. The only problem with that is that it needs a model, and models cost money, which you would be paying on top of whichever model you would be using when interacting with whichever other agent you might be hooked to kubectl-ai acting as an MCP server. So it's great as an MCP server, but that greatness might not be great enough when compared with other MCPs that interact with Kubernetes clusters. As such, I wasn't sure whether to put that one as a pro or a con. Nevertheless, I chose to ignore the cost and say that it is great. Not necessarily as an agent, but as an MCP server. Okay, so I truly believe that kubectl-ai would be great, and that I would not have any serious complaints about it if it was released last year. That's not the case though. It was released in April 2025. Last year, our expectations from AI agents were very, very different. They were much less capable than they are today. Today, however, we can get just as good or better results with other agents. If, as an example, we did the same exercises with Cloud Code, which is also a terminal-based agent, we would get better results even without the usage of persistent memory or MCPs. Moreover, not only that the outcomes would be better when working with Kubernetes alone, but we would also have the benefit of being able to use the same agent for other tasks that are not strictly related to Kubernetes. So, the question is, why would anyone choose kubectl-ai over, let's say, Cloud Code, or Cursor, or Windsurf, or any other more generic agent? Normally, I would say that kubectl-ai is more specialized. It is focused on Kubernetes, and as such, it performs better when Kubernetes-related tasks are concerned. That would be an important advantage. I would be more than happy to use multiple agents, one of them being kubectl-ai when working with Kubernetes. However, as it stands now, it makes more sense to use Cloud Code for everything, including Kubernetes related tasks. All that is not to say that it is bad. If you work only with Kubernetes and you don't need MCP servers and you don't need persistent memory, then kubectl-ai is a good choice. It's better than other agents focused on Kubernetes. The problem is that there are too many ifs. On the bright side, kubectl-ai is a very young project. I'm sure that all of the cons I mentioned will be fixed soon, and when that happens, kubectl-ai will be a good choice. But only for those working only with Kubernetes. At some later date, the community behind it might come up with features that make it a better choice than more generic agents. If that happens, I will surely adopt it. Until then, thank you for watching. See you in the next one. Cheers.